Hi dears, let's see here CSIR NET 2022 question. Let f comma g from R to R is given by f of x is equal to x square and g of x is equal to sin x. Which of the following functions given here is uniformly continuous on a real number? So let's see here, let f of x is equal to x square and g of x is equal to sin x, right? So x square is the function which is not uniformly continuous on real number, and the sin x which is the function uniformly continuous on R. So in R, this polynomial is not uniformly continuous, but the sin x, which you know that modulus sin x which is less than or equal to 1 bounded, so which is uniformly continuous on R, uniformly continuous on the real number. So let's see the by option wise. The first one here, option A, h of x is equal to g of f of x. So g of f of x here is x square, and which is equal to g of x square, which is equal to sin x square. Alright. Now I am taking the derivative. So h dash of x, which is equal to cos x square into 2x, the derivative. So as x tends to infinity, because in the real number system, so h dash of x is also tends to infinity. So that we can say that option A is not uniformly continuous. So the uniformly continuous exists only when if it is a bounded condition. Let's see the B part. So the B part is h of x is equal to gx into f of x. So h of x which is equal to f of x, g of x into f of x. G of x into f of x. So which is equal to g of x is sin x and f of x is x square. Right? So that h of x is equal to this value, and h dash of x which is equal to sin x into 2x then plus x square into cos x. Here also, as x tends to infinity, you can see here h dash of x is also tends to infinity. So that option B is also not uniformly continuous. Let's see the third option, EF into g of x. So the third option, h of x is equal to f into g of x, and which is equal to f into g of x is sin x, and f of x is equal to x square. So substitute this one, sin x the whole square, right? So that you can see here f into sin x which is equal to sin x the whole square, which is equal to sin square x. So if you see h dash of x which is equal to 2 into sin x into cos x. So it is equal to sin 2x. So here you can see if you take the modulus of this one, h dash of x which is equal to modulus sin 2x, yes, throughout the interval x belongs to R, you can see throughout the interval it not tends to infinity but less than or equal to 1. So sin 0 value that is equal to 0, then you can see that sin 30 degree that is equal to 1 divided by 260 degree, then 90 degree which is equal to 1. In between, what are the numbers? You can see that the number won't exist more than these values. So that we can say that sin 2x value less than or equal to 1 for all x belongs to the real number. So it is bounded condition, so that this implies uniformly continuous. So option C is the right answer. Let's see the option D, h of x which is equal to f of x plus g of x. So that which is equal to x square plus sin x, and h dash of x which is equal to 2x plus cos x. So as x tends to infinity, that is belongs to the real number system, you can see that h dash of x that will be tends to infinity. So option D is also not uniformly continuous. So from this four option, option C will be the right answer. That is option C, h of x is equal to f into g of x, which is uniformly continuous of the real numbers. Thank you.